This is the Ultrapyc 5000. It sits here on the table. This is the instrument itself. Next to it are the calibration spheres. In the drawer down below are the manuals and alternate sizing holders. And then it is connected to a helium gas tank. This right here reads the pressure in the tank as long as this is open. Right now you can see we have a little over 2000 psi. That means this is a fairly full tank. As with any gas in the MCL, if you ever see the first regulator closest to the tank get down to 500 psi or lower, that's where we consider it to be empty, and you should contact lab staff or talk to someone who can order a new one for the lab. This right here is the output pressure. The maximum that we'll see on the Ultrapyc is 20 psi, which is where it's set right now in those red numbers. It will be set anywhere between 20 and lower down to about 2 psi. You can change that by adjusting this knob right here. You can see arrows to decrease or increase the pressure coming out of our regulator here into the Ultrapyc. In the drawer below the Ultrapyc, you will find the red manual here. This is a very well-written manual and has a lot of walkthroughs that are very easy to read. So any of the information in this video can be found in this manual as you're at the instrument. You'll also find the baggie full of our different sized cells. We have 6 different cells ranging from large size down to micro, meso, and nano sized cells. Each of these cells gives us the ability to change the interior size of the instrument, and that will allow us to run different sized samples depending on how much material you have or how large your material might be. If you have anywhere between 10 and 50 centimeters cubed of material, so that's a volume there, you would use the medium cell. The medium cell has a sleeve to contain your material and a big solid base, which is going to fill up the remaining space in the sample chamber in the Ultrapyc. The sizes go as follows. If you have a large sample, or if you have a sample between 50 and 130 centimeters cubed, you will use the large sleeve. If you have between 10 and 50 centimeters cubed, you will use the medium sleeve. Or if you have between 5 and 10 centimeters cubed, you'll use a small sleeve. The micro, meso, and nano sleeves have an additional piece to them, which is this adapter right here. This is going to fill up the bulk of the space in the sample chamber, and then you will place your micro, meso, or nano sleeve, as shown here, into the machine. These are an adapter to the machine, so they are slightly less precise than if you were to use a larger cell. So if you are able, I would recommend trying to fill one of the larger cells rather than using the small adapter. However, the small adapter is great if you have very, very small amounts of material. If you have between 2 and 5 centimeters cubed of material, you'll want to use the micro cell. If you have between 1/4 and 2 centimeters cubed of material, you'll want to use the mesosphere, or the meso sleeve. And if you have anywhere less than 1/4 centimeter cubed of material, you will want to use the nano sleeve adapter. To put the correct adapter and sleeve into the machine, pull out the corresponding bag from the drawer and pull off the lid. Instructions to take off the lid can be found on the top of the machine. We're going to loosen the top and then loosen the bottom and then lift this straight off. Please make sure that you set this on a nice clean surface so that we don't get any dust or dirt on the bottom of our lid. Next, you're going to take the adapter, which is the big heavy metal piece, and you're going to gently slide that in. Please do not drop it in to avoid damaging the machine. And then we're going to put in the sleeve adapter. This sleeve adapter is what's going to hold our sample, whether that be a monolith, meaning a solid sample, or some sort of powdered sample. Before placing any material in here, it needs to be weighed so that you know the exact gram amount of material that you have. When you first come to the machine, you're always going to run a calibration, meaning that we are going to use some spheres with a known volume and mass. And we're going to run those first to ensure that the machine is running at a good, with good parameters and such. To the right of the machine is a box that says Anton Par on the top, same as the machine itself. This box has a set of spheres, large, medium, small, and then micro, meso, and nano are these three right here. And we're going to use these to calibrate our instrument. So what I'm going to do, instead of putting a sample in here first, I'm going to grab the medium ball and I'm going to place it into the sample sleeve. Again, to avoid damage to everything, I'm going to put it in nice and gently, and then very gently lower this into the machine. So this is going to be my calibration sphere right here. Next, I'm going to put the lid on by just doing the inverse of what I did earlier. This should rotate very, very easily. If this is not rotating easily, the lid needs to be pulled off and set back down again because it's a little sideways, which is pretty easy to do. So we're just going to rotate that until the white line lines up with the lock there, and then we're going to rotate the top until it lines up as well. So now my sample is inside the machine, and I'm going to go to the screen to set up my calibration run. At the start of each session of using the Ultrapyc 5000, or any time you change the settings significantly, such as the temperature, pressure, or size of the cell that you're using, you want to recalibrate the instrument to make sure that it's using the proper parameters. We'll do that by making sure you're on the home screen by pressing the home button on the left side here. And press calibration, and we're going to calibrate the sample chamber. You want to set up the settings to be as similar to your run settings as possible. Cell size, we can select from small, medium, or large. If you are using the micro, meso, or nano cells, please select small. Otherwise, select the corresponding cell. We are using medium today. Set your target pressure. That can be anywhere between 2 and 20 psi. Whatever you set your target pressure to be, you want to set the regulator at the tank of helium to be within about 2 psi, a little bit above, so about 2 psi above the target pressure. If you have a monolith, meaning a solid sample, you want to use about 18 psi. If you have a powder, you want to use about 10 psi. If you have a brittle or a biological sample, you want to use 4 psi. If you're using the micro, meso, or nano cells, you want to use 10 psi or less, since they are not able to withstand larger pressures. For us today, we're going to be doing a powder, so we're going to do 10 psi right here. Temperature control, we have a range between 20 degrees and 50 degrees Celsius. If you do not wish to have any unusual temperatures or to see the heightened temperature of your sample, choose 20 degrees Celsius, as that is typically the room temperature in our lab. If you want to go any higher, please allow at least 20 minutes for your sample to sit in the instrument between the calibration and the run in order for your sample to come to a temperature equilibrium. We're going to just run this powder at room temperature right here, so we're going to leave it at 20 degrees. Next is end mode. Automatic is the best option for this. This is going to take several data points, and it's going to stop the test when it has several data points that are within 0.005% of each other, meaning that you have 0.005% error. The maximum number of runs it will do is 15, just in case it takes a very long time. You're not having the test run forever. It will run either until it gets a 0.005% error in your answer, or it will do 15 runs. If you choose not to use automatic, it will run a set number of runs, which you can set. Typically, you want to run 10 or more to make sure that you're getting less error, but it is recommended to do automatic. You can see we have lots of different options here of precision. The normal precision is 0.005%, but we can do as precise as 0.0025%, or we can go a little more coarse and do 0.1%. Maximum number of runs, it is recommended to do 15, but if you're having issues with your sample, you can go longer or shorter depending on your needs. Our gas is helium, and our flow direction, we have options of sample first, reference first, or both. If you have a monolith, meaning a solid sample, you want to do sample first. If you have a powder or something that is likely to splash as air is added to the chambers, you want to do reference first. If you are going to be doing both monoliths and powders in the course of your testing and you want to use the same calibration for both, choose both. For us, since we are going to be doing a powder, we're going to choose reference first. Once this is all set up, we're going to hit continue. Now remember, I have my medium cell or my medium sphere already in the sample cell, and it does prompt me to put the medium sphere in there, and it tells me what the volume of that medium sphere is. If you are using a sphere that is not indicated on here, large, medium, and then the two smalls here, for example, you're using the micro, meso, or nanos, you want to use a custom volume right here. You can find the volume of the cells located in the manual on page 18. So I'm going to hit continue, and now it's going to run our calibration test. This typically runs less than half an hour. If it runs longer than half an hour, it is always less than 1 hour. Here you can see the calibration is complete. It took about 5 minutes to run, as you can see here. You can review the measurement settings and look at the results. We have a pretty good percent variance here. Successful calibration. We're going to go back to the home page now. We're going to start our measurement. At this point, you would remove the lid and take the calibration sphere out of the sample cup, and you would put your measured amount of material in there. Here I have measured out 26 grams of just an ice melt salt. And I've placed it here in the sample cup. I'm going to very gently lower the sample cup into the container here and place the lid back on, just like before. Because my sample salt has been sitting at room temperature, I am good, and I am running this at room temperature, I'm good to start it whenever I'm ready. Back at the screen on the instrument, I'm going to press the home button to make sure that I'm on the home page. And this time, once we've got a finished full calibration, we're going to go to measurement here. I'm going to type in the name of my sample here, which will be ice melt. It's a good idea to put a date with the name of your sample, especially if you're going to be running samples that are similar to one another. And I'm going to press this little gear icon here to go into the settings of this ice melt run. So I'm going to type in my sample weight in grams, and I have 26 exactly. I measured out exactly 26 grams. And now we're going to go through each of these settings. End mode, just like was done in the calibration section, this can be either automatic or fixed. Automatic is what is recommended. That's going to give you a very low percentage of error in the set of your runs. We have a range of less precise to more precise. 0.005% is the typical recommended. We're going to set a maximum number of runs so that it does not keep running forever in case it's having a very difficult time in narrowing down that error margin. And then we're going to select runs to average. What's going to happen here is it's going to run 5 sequential runs, and it's going to average those 5 together. If the error within those is 0.005% or smaller, it will stop the scan there. That would be a very fast and a very reliable scan. However, if after the 5th one it does not have this low error percentage that we've selected, it's going to run a 6th, and then it will average runs 2 through 6 to try to get this error percentage. It's going to do that all the way up to a maximum of 15 runs. If it hits 15 runs, whether or not it's hit that 0.005%, it's going to stop your scan. You can change those as you need, but 15 and 5 are the traditional or the normal. If you choose to do fixed, you choose the number of runs and the number it will average, and you will have to calculate your own error percentages if that's something that matters to you. Preparation mode. This is how the gas flows into the cells. Flow is to be selected if you have a solid or if you are using the micro, meso, or nano cells. Typically this ranges between 1 and 3 minutes. If you are trying to analyze a more porous sample, you're going to choose 3 minutes rather than 1. The other option is pulse here. Pulse is typically for a fine powder or a sample that may splash around as the gas is added. It is recommended to have 9 pulses. You can increase or decrease that. Target pressure mode. This is the pressure of helium that's going to be in the system during the test. We can range anywhere from 2 to 20 psi. For a solid sample, also called a monolith, you would want it to be around 18 psi. For a powder, or for the micro, meso, or nano cells, you want it to be 10 psi, which that is true for ours. And for a very brittle sample, or for biological samples, you would want to put 4 psi. For the micro, meso, or nano, you can do 10 psi or smaller. At this point, you would want to turn to the regulator at the gas tank and turn it so that the output pressure to the machine is about 2 psi higher than the target pressure. So in this case, I have my target pressure at 10 psi. I would want about 12 psi to be coming from the tank to the machine. Flow mode, we're just going to select our type. I have both coarse and fine powder in my ice melt material. I'm going to choose fine powder. That is the more, oh come on, there we go. That is the more conservative of those 3. We want to choose the smallest thing that accurately represents your samples. In temperature control mode, we're going to tell it whether we want it to control temperature over the course of the test. Typically we do, and this ranges anywhere between 20 and 50 degrees Celsius. Usually we set it to be about 20 degrees Celsius. If you want it to be higher than room temperature, you would change this temperature here, and then click Save. At this point, you would want to wait for 20 minutes before clicking Start on your test to allow the machine and your sample to get to the temperature that you are running at. Next is flow direction. If you are running a monolith, meaning one single sample, you want to do sample first. If you have powder samples or something that's going to splash, you want to choose reference first. Next is equilibration. There are 3 options for the equilibration criteria. We have fixed time, pressure, or temperature and pressure. Fixed time is going to be the fastest, which also means that it's the least precise of the 3 options. Fixed time means that it is going to take data values every 3 minutes throughout your test. So that means that one cycle will take 3 minutes. If you remember from earlier, we will do a maximum of 15 cycles, so that we know exactly how long our test might take. This is fastest because it is not basing the equilibration time off of anything that's happening in the machine. So if your sample is taking longer to equilibrate to the temperature or the pressure settings, this is not going to pay any attention to that. The next most precise option is pressure. That means that it is going to wait for the pressure to stabilize fully before moving on to the next cycle. We don't know how long that's going to take. That's going to be kind of based on your sample and the internal workings of the machine. And we've got stability criteria here: standard, fast, or high precision. High precision would be for if you are trying to publish this data that you receive from the Ultrapyc 5000. Fast would be for senior projects or lab classes. And then standard would be for most other cases. The third equilibration criteria is temperature and pressure, meaning the machine is going to wait until the temperature and the pressure are both stable through all parts of the machine before moving on to the next cycle. This is the most precise of the 3 options for equilibration criteria and is going to give you the best results, but is also going to take the longest. Again, we have 3 options for stability criteria: standard, fast, and high precision. Choose those based on your application. Next is cell size. We're going to choose whatever we just calibrated. So we just barely calibrated the medium cell, so we're going to use the medium cell size. If you're using the micro, meso, or nano cells, you should have calibrated to the small option, and you would want to select that one for your run. Gas type is helium. We only have helium as an option here. And then we'll click Save. Now, unless you are waiting for the temperature, which is pictured up here in the top right corner of the screen, unless you are waiting for that to reach a temperature other than room temperature, you can go ahead and click Measure. If you are waiting for your temperature, I would recommend giving it a minimum of 20 minutes to make sure that it is nice and stable before moving forward with your measurement, to allow your measurement the highest chance to succeed. So we're going to click Measure, and it shows this little schematic of the device. We've got gas coming in, and we've got our sample cell and our reference cell, and then gas flowing back out. Down here at the bottom, you can see run 1 of 15. That is the maximum number of runs that we told it we wanted it to run. It will most likely not run a full 15 scans, but it depends on the precision that it's able to get from my particular sample. These tests can run anywhere from a few minutes to a few hours. As you get to know your sample and your application a little better, you'll have a better idea of how long these tests can take. As you can see, we've reached the end of this salt test. Our density value is labeled here, 2.1592 grams per centimeter cubed. I'm actually pretty thrilled about this result because the density of table salt, just plain sodium chloride, is 2.16, which is pretty much exactly the density that we got here. So my ice melt here is almost pure salt. You can see average volume right here, which mass divided by volume gives us that density value. You can see my percent variance, which I set to be 0.005. You can see my actual error is 0.0053%. And you can see all of the tests that it ran. This one actually took 15 tests to run. If I had set the value to be a little bit higher, based on the fact that I have pretty close to 0.005% variance, I am going to guess that it would not have taken many more tests for me to get to a true 0.005. So this test did time out because it did take the full 15 tests in order to get, well, it would have taken more than my full 15 tests to get my true percent variance here, but we did get really low error and a really awesome value for my density here. To export your results, plug in a USB to one of the 2 ports down here at the bottom, and then click this Save icon right here. That's going to create a folder on your USB called Pyc Data, PYC Data, and you can save your result as either a text or a PDF file by selecting the file extension down here at the bottom. Then click Save, which I've already done, so I don't want to save over my file. This is the one exception to the rule that we cannot have personal USB drives in the MCL. In this case, in this machine only, you are allowed to plug in your own personal USB to save the data directly onto your own drive. If you don't have a USB with you, you are welcome to grab one of the MCL's USBs, plug it in, save the data to one of our USBs, and then take it to one of the computers that has the internet and email those results, either the PDF or the text file, to yourself. Please make sure that the USB stays here in the lab and does not leave. Also, please make sure that you do not plug our personal or our MCL USBs into your own personal devices. Make sure that those stay only lab USBs. If later you want to find the results again, from the home screen, you go to Data Explorer, and you can see measurements, calibrations, and leak tests. You won't need to run leak tests, that's something that lab staff will do, but you can run back and you can see this is the calibration we ran earlier today. And under measurements, we've got ice melt here at the top. We can go back, we can see those results again, and we could export that data again if we needed to. At this point, you would open up the top, pull your material out and put it back into your own receptacle. If it's safe to go in the municipal trash can, you can throw it away here or take it back with you. Then make sure that you clean off the adapter and the sleeve for, in our case, the medium cell here. Clean those off with a little bit of isopropyl alcohol or acetone to make sure that there's no residue of your sample. Place them back in their plastic baggie and return them to the drawer beneath the Ultrapyc. If you are finished running tests for the day, also make sure to turn off the helium tank to the right of the instrument.